Wormholes are often described as portals that bend our universe and space-time itself. For a long time, people believed this description. They imagined giant tunnels connecting distant parts of the cosmos, allowing spacecraft to travel from one side of the galaxy to the other in an instant. But this is not how the idea originally appeared in physics. The concept of a wormhole comes from Einstein's general theory of relativity. In this theory, gravity is not a force pulling objects together. Instead, mass and energy curve spacetime, and objects simply follow those curves. The foundation of general relativity is Einstein's field equation. This equation tells us something remarkable. The right side describes matter and energy. The left side describes the curvature of spacetime. In simple words, matter tells spacetime how to curve, and spacetime tells matter how to move. In 1935, Einstein and the physicist Nathan Rosen studied solutions to these equations. They discovered a mathematical structure that connected two regions of spacetime. Today, we call this structure an Einstein-Rosen bridge. At first glance, this looks exactly like a shortcut through the universe. However, there is a major problem. Einstein's original bridge is unstable. The tunnel pinches shut so quickly that even a beam of light could not travel through it. If you tried to enter one side, the bridge would collapse before you could reach the other end. This means Einstein never proposed a traversable portal for space travel. The famous science fiction version of a wormhole came later, when physicists began asking whether such a tunnel could somehow be held open. To keep a wormhole stable, calculations suggest that you would need something called negative energy density or exotic matter. This is strange because all ordinary matter we know has positive energy. Some quantum effects can produce tiny amounts of negative energy, but we have never found enough to hold open a macroscopic wormhole. A simple way to visualize a wormhole is to imagine a sheet of paper. If point A and point B are far apart on the paper, traveling between them takes a long time. But if you fold the paper so the points touch, you can move directly from one point to the other. The distance through normal space might be millions of light years, while the distance through the folded geometry could be much shorter. The important thing to remember is that wormholes are not proven cosmic highways. They are mathematical solutions hidden inside Einstein's equations. They show us what might be possible according to the geometry of spacetime, but we have never observed a real wormhole, and we still do not know whether stable wormholes can exist in nature. So the biggest misconception about wormholes is not that they bend spacetime, it's that Einstein discovered a portal. He didn't. He discovered a mathematical bridge, and decades later, science fiction turned that bridge into a gateway across the universe.